All right, let's talk cloud security. For a long time, we've relied on old methods, but with cyber threats getting smarter every day, those methods just aren't cutting it anymore. So today, we're going to dive into a pretty huge shift in thinking: how to build a seriously resilient system on AWS using something called a zero trust approach. Let's get right into it. Okay, so the whole idea of zero trust, it really boils down to one simple but super powerful motto: never trust, always verify. And look, this isn't just some catchy slogan for a poster. It's the core rule that's going to guide every single security decision we talk about. It means we throw out all our old assumptions about who or what is safe on our network. So for the longest time, security was basically built like a medieval castle, right? You'd have this massive outer wall, your perimeter, and the thinking was anything that gets inside is automatically trusted. But you can probably see the huge problem with that. As soon as one attacker gets over that wall, they have the keys to the kingdom. It's game over. Zero trust completely flips that script. It says, forget the inside and outside. There is no trusted zone. Instead, every single request from anyone, anywhere, has to be authenticated and authorized. Why? Because we're not just thinking a breach is possible, we're assuming it's going to happen. So to really get this, we have to kind of shift our whole mindset. We're moving away from that old castle guard mentality and thinking a lot more like airport security. I mean, think about the last time you went to an airport. You don't just flash your ticket at the front door and then get to roam around wherever you want, right? No way. Your ID gets checked when you drop your bags, then it's checked again at the security line, and then again right before you board the plane. That's the perfect real-world example of zero trust. It's all about that constant verification at every single checkpoint. All right, so let's break down the core principles. The first one, and honestly the most important one, is this: never trust, always verify. I mean that literally. I don't care if a request is coming from inside your fancy corporate headquarters or from a coffee shop halfway around the world. Every single user, every device, every app has to prove who they are and what they're allowed to do for every single request. No free passes. Okay, building right on top of that, we have principle number 2, enforce least privilege. This is a huge one. All it means is that you give people and systems the absolute bare minimum permissions they need to do their job. Nothing more. So if an app just needs to read data from a database, it should never, ever have permission to write or delete. By doing this, you seriously limit the damage if an account gets hacked. We call that minimizing the blast radius. And finally, our third principle. And this one requires a real change in how you think. It's assume breach. So you stop designing your systems with the hope that an attacker will never get in. Instead, you design it with the stone-cold expectation that they're already inside, or they will be very, very soon. It's a bit pessimistic, I know, but it completely changes your priorities. You start building systems that are amazing at detecting, isolating, and responding to threats, instead of just trying to build a taller, thicker wall. Okay, so that's all the high-level philosophy, the why. But what about the how? How do we actually take these ideas and build them on AWS? Well, let's open up the AWS toolkit and see which services map to which principles. So here's a quick cheat sheet. For that never trust, always verify principle, our go-to tools are going to be AWS IAM, that's Identity and Access Management, and the AWS Web Application Firewall, or WAF. Then, for enforcing least privilege, we're really going to lead on fine-grained IAM roles and specific type policies, especially for things like our S3 storage buckets. And finally, for that assume breach mindset, it's all about solid Amazon VPC design for network segmentation and using AWS Private Link to make sure our services can talk to each other without ever touching the open internet. All right, let's make this way more concrete. Enough theory. Let's imagine we're building a simple internal API. How do we apply this blueprint to lock it down at every single layer? Okay, so the key here is thinking in layers. It's defense in depth. First up, the network layer. We're going to use VPCs and subnets to wall off our API from everything else. No more wide open security groups. And we'll use AWS Private Link so that other services inside our network can call the API privately without ever going out to the public internet. Cool. Next, we move up to the identity layer. Here, our API gets a super specific IAM role. It can do exactly what it's supposed to do and nothing else. And then finally, at the application layer, we'll stick AWS WAF in front to filter out any nasty traffic. And if that API needs to grab data from, say, an S3 bucket, it has to use a very strict identity-based policy to do it. See? Every single layer is checking and verifying. Now, I know this can feel like a lot to take in all at once, but the good news is you don't have to boil the ocean. You can get started today just by focusing on a few really actionable patterns.
In fact, let's just boil it all down to 3 key things.
Okay, here they are. Pattern number 1. Secure all the communication between your resources. Stop using public IPs for internal traffic. Think private link. Number 2, grant access to everything based on super granular least privilege permissions. Time to kill those God mode roles. And number 3, this is the big one we keep coming back to. Authenticate every user and every system for every single request. No exceptions, period. So, as we wrap this up, I want to leave you with a little homework, a question to take back to your own team. Take a hard look at your architecture. What is the one, just one, trust assumption that you're making right now that's probably a bad idea? What's one thing you trust implicitly that you could start verifying tomorrow? Find that one thing. That's your first step on the zero trust journey.